Good afternoon. Put in an extra helpful lecture here about chirality. It's an article by Hélio da Motta1. Chirality and Neutrinos. It should be seen as a primer to this most difficult subject. Forbiddingly difficult. Abstract. Does nature care about left-handed and right-handed configurations? Are left and right just two versions of the same thing? Although at first we may think that a particular orientation is irrelevant, the fact is that nature may distinguish between left-handed and right-handed systems. This results in different behaviors and properties. In this short presentation, we will approach the phenomenon and how it affects the neutrinos. Introduction. Figure 1 shows two photos, Katarina and Katarina, as seen on a mirror. Can we take the real Katarina from her mirror image? And what about cuckoo clocks from figure 2? A detailed observation of figure 1 will not help us to tell the mirror from the real image. The same is not the case for the cuckoo. We can see that the cuckoo clock on the right has the numbers displayed counterclockwise. And we can read Inam Greg Ni Edan at the bottom of the display. The clock on the right is the mirror image. And I continue here. Both of Katarina's pictures are possible representations of a girl. This makes it impossible to tell the mirror from the real image. Although we can certainly make a cuckoo clock with everything reverse, a counterclockwise clock is not the pattern. The fact that we build clocks the way we do, the clockwise way, is basically a question of choice. We have chosen to do so. What about nature? Does nature also choose a particular orientation? Well, the surprising answer is that it many times does. Helicity. Let's consider a spinning body in movement and project the spinning on the direction of movement, like this. only care about the spinning in the direction of movement. Helicity is the projection of the spin along the direction of the movement. It is right-handed if it is parallel to the movement, and left-handed otherwise. The direction of the spinning is defined by, and now important, the right hand rule. When holding the body with the right hand, with the fingers following the spinning, the thumb points in the direction of the spinning. So take your fingers, put them over the direction where the spinning is, and your thumb will tell you where it's heading. That can be applied to any moving object. Let me repeat. You put the hand over the spinning. Let's imagine this thing is spinning in a certain direction. That direction. Put it over, and the directionality will be told by the right hand thumb. This is extremely hard to do in the head. You need to use your hand. That goes to show how hard helicity and chirality are to sort of abstract. And in my view, that is one of the reasons why it so eludes human understanding. It then has a right-handed helicity. Helicity. The figure on the right shows a body also moving to the right, but with a spinning in the opposite direction. It has left-handed helicity. And the rule of thumb is done even by the most advanced physicists, mathematicians. I think that's most definitely point to the absolute necessity of a human body. If we are moving in the same direction as the spinning body, we can see the body moving forward. If it is going faster, or backwards if it is going slower. Or not moving at all if we are moving at the same speed. The spinning does not change though. Helicity will then be right-handed or left-handed, depending on the frame of reference. Helicity is not an intrinsic property. Elementary particles like electrons and neutrinos are considered point-like and cannot spin like a soccer ball. But nevertheless, they have an intrinsic spin and a present right-handed or left-handed helicity, depending on the frame of reference. Although the spin is an intrinsic property of a particular particle, hard to pronounce, its helicity, as described above, depends on the frame of reference. Do you remember that frame of reference? As long as we can move faster than the particle, and now to the magnificent question. is there anything related to helicity that is invariant and does not depend on the frame of reference? Big question mark. Figure 4. If I rotate like a rotisserie chicken, figure 4, observers in different frames of reference will disagree regarding my helicity. Remember the thumb and where the spin is going, its direction. But there will be no doubts about which one is my right hand and which one is my left hand. And that brings us to the amazing thing of chirality, not dependent on frame of reference. Figure 5 shows a screw, a nail and their image as seen on a mirror. The screw cannot be superimposed on its mirror image since they have threads with different handness. Right hand in the screw and left hand in the mirror image. The nail, however, can be superimposed on its mirror image. An object that cannot be superimposed on its mirror image, it's said to be chiral. Surely we can make screws of any orientation, right or left-handed. Therefore, in principle, we could not identify the mirror image as a not real screw. We basically choose to build right-handed or left-handed screws. Nature can do the same. And surprisingly, in many instances, decides for just one of the two. Many molecules are chiral and found only in one of the configurations. The well-known bDNA and aDNA helix come only in a right-handed version, while the zDNA comes only as a left-handed helix. Figure 6 shows the structure of the DNA where its orientation is visible. Figure 6 also depicts a chiral molecule. A mirror image of a bDNA would be right-handed, but it simply does not exist. The mirror image of the molecule is also not found in nature. We cannot place a particle in front of a mirror to find out if it is chiral. However, particles belong to the quantum realm, where a particle is represented by a wave function depending on the space and time coordinates. As you all know, x, y, z, t. Figure 7 shows the effect of reversing the axis of an x, y, z frame. It produces its mirror image, changing the system from right-handed to left-handed. it comes out that the neutrino is chiral, and only the left-handed version is observed in nature. Nature provides us only with neutrinos which are left-handed chirality. The neutrino antiparticle, the antineutrino, comes only in its right-handed chirality version. One may ask, and so what? Start liking Hélio. Let me just sum up this rather hard thing. So chirality is the only property in the universe which is not explicable or dependent on a frame of reference. All other properties, up, down, big, large, small, and so on, are explicable and dependent on frame of reference. This one is not, and I think nobody knows about it. Now comes a rather technical description of helium, and it shows that how the particles, or whatever you call them, particles would be a bit too strong, but depending how they are chirally, they interact in different ways. They build up the universe because of their chirality. So what makes up a particle is its chirality, how it is twisted. So the chirality, the handedness, if the neutrino is right-handed or left-handed, makes what it is. So handedness are the most fundamental building block in the universe. And do remember that the antineutrino is so incredibly different, so it cannot even exist in our normal universe. It will immediately evaporate. Particle mass and chirality. In the standard model, all particles are created massless and left-handed. And antiparticles are also created massless but right-handed. particles acquire mass when interacting with the Higgs field. Once created, the particle starts interacting with the Higgs field. As more a particle interacts, more mass it acquires. If a particle does not interact with the Higgs fields, then it remains massless. Each interaction with the Higgs produces mass and keeps everything else unchanged, except for the chirality that is reversed at each interaction. A particle then acquires mass and develops a right-handed chirality component. Or a left-handed component for antiparticles. The right-handed and left-handed components will not necessarily be equal, and as more energy the particle acquires, the bigger the right-handed component. The electron we observe is a mix of left-handed and right-handed electron. So what you see here, that as opposed to all current thinking or understanding, the most important features of the universe are not dependent on a frame of reference. They are actually non-reducible non-reducible they are internal, which means they are not dependent on a frame of reference. And for clarity, I will write not dependent on a frame of reference. All these things are unknown to the public, I would say, because I think most commonly people think that all features of the universe can be reduced to a point of reference and thereby made absolutely relative to everything else, giving them a feature of being nullified or unimportant. Internal. Who would think that the universe is internal? No one. Non-dependent on frame of reference. I think it should be an A here. Possibly. We put in an A here. And I think what's tricking people today is that maybe the first step, we think we can decide everything in relation to a frame of reference. Therefore we get up, we get down, we get front and back. But this shows, and I think you can understand that without this even, it's one of those things that are developing now as we speak in the modern age. They will all become like a thread on a jumper that's too old and made in the old fashion. Start pulling one of the threads and the whole jumper will disappear in front of your eyes. The thread is dependent on the constellation and it can be undone. It's a bit like our bodies will go into another state and somehow become undone. Ashes. The view of postmodernism is not a view, it's an accurate conclusion from not understanding chirality, which is, I would say, almost unknown. Hélio da Motta1 is one of the few I could find that written anything about this. And you don't have to be explicitly postmodern, your thinking will still come unglued somehow. It will not be founded. And as we know now, and I spoke about that earlier briefly, even our body is chiral. So our very, very constitution is in itself chiral. Our balance, our stability, our thinking processes are chiral. All the neurons are chiral, dependent on chirality. The only thing that is not chiral is us trying to convince ourselves and all others, I would say, that everything is like the jumper that can come unglued. A bit like putting ice in hot water, it just disappears. This is not true from a quantum mechanic perspective. And I think it's a changer of everything. But it is hard to understand. I often recommend to see the two opposing things as mirror images. That goes for helicity. But actually chirality is one step further complicated. Well, complicated, it's in front of our eyes. I had hands myself. Yeah, I got two. They are not mirror images. They are internally different because of how they work. And that cannot be explained by anything else. It is fundamental in the way, non-explicable. I think my colleague here, Kalle, is most anxious to have a comment.
Anxious, not. Is it okay? So, Chirality, it comes from the Greek hair, which means hand, which means yes, hand. And the idea is that you have two hands, they are never the same. That is, you can try it out, putting this close, and if you on your left hand, and then if you, what do you call it? You take it out, and so to say, take on from, what do you call it? You roll it out. You take it out, and then you roll it back again, but backwards, so to say. This close you can do that. So to say, I don't have this close with me, but you can put them backwards on, and that shows that there is a fundamental asymmetry in nature, but that they're still the same. The left hand will suit the right hand if you use a disc glove. And you can think about Escher's drawing hands. Can we use the principle of these three things to Escher's drawing hands? Non-reducible. Perhaps, I don't know. They are true in themselves. The one hand draws the other hand. And the internally, you don't need in an external somebody who explains them from the outside. Even though we know that there is Escher himself, perhaps, I don't know, it's difficult to say. And there is, no, I don't know. It's a difficult subject. What would you say, Hans, about the Escher's drawing hands? Can you relate this to that?
Well, I have to add, this is a new subject for me as well, and you can't take, well, with the exception of this small course, 1 week course, I can imagine from Brazil, there is nothing to be read. It is tough, it's a tough nut to crack, but see the glove, the very good with the gloves. You see, if you take it off, it's something that goes on in the whole of space. It's not from the outside of the space, X, Y, Z, it's inside. And that also shows the chiral nature of space itself. And next time we don't use dish gloves that much in Sweden, but I probably can find a pair anyway. They're very common in England. But if you turn it upside down, it's very good to understand chirality and how it is internal. That's the most important point. The building blocks are dependent on this asymmetry, non-reducible asymmetry. Other asymmetries that we usually perceive in everyday life, they are actually, most of them actually reducible. Like if you get too much acid, you add some alkaline stuff and whoops, disappears. You get pH 7. If I go a bit to the right, I can go back to the left. I'm not fooling around. I mean, this is seriously how we usually perceive things, and how I did until recently. Everything becomes nothing in the end. And it makes it impossible to have a localization, which is very interesting. You are nowhere, since all the directions we're using today, back, front, up, down, are absolutely relative. Everything is absolutely relative. This is no coincidence. This is the same way Einstein thought about the universe, where everything is relative and there is no chirality there. It is not relative, oddly enough. It is what I call internal, and the fun guy Hélio He must be fun because he puts himself on a skewer and pretends he's a chicken. It's fun enough. It is actually internal, and it cannot be erased by a frame of reference. And it cannot be reduced even in explanation. And that's the Gardner example, if you remember. Gardner showed that if you were to be contacted by an alien civilization, usually called Ozma, for some reason, I don't know. If we want to explain to them everything that we have around us, it wouldn't be a problem. We can write it down, we can use the coordinate system. But if you're going to explain to them that I am right-handed, I have a right hand, that cannot be transferred. It doesn't matter how much information we send. It is absolutely impossible. It can only be shown. It's an internal feature. And who knows this? I don't know. No one knows this. Interesting to see where that leads us, but it's...
Would they get the SS drawing?
No.
No.
They wouldn't get it. Because it would look like one hand drawing another one, but you need to understand what right and left is. That is the problem. Would be a beautiful drawing anyway, maybe, for the Ozma inhabitants, but it wouldn't be paradoxical in that way, because that takes you to have a right hand and a left hand. And even if they had a left hand and a right hand, they wouldn't know which hand I was talking about. It is truly internal. I think it's a time for the public to know about chirality. Any comments? It's amazing. I'm an engineer and I've known about something about this, but I confused helicity.
We can perhaps finish by showing the funny image.
Yeah, that's a fun guy, if there is anyone. I'll give you some light here. Here we have himself. He's absolutely happy. He's on a chicken skewer. Good old Hélio da Motta1. I say thank you for listening, and thank you, Hélio da Motta1, to be one of the very few ones who are willing to at least put a few pages on trying to explain.
Chirality.
Yeah.
Thank you.
Have a very pleasant afternoon. Bye-bye for
good
now.
long Friday.
Have a good Friday, or some Viernes Santo.